So from today we'll start integral calculus. Okay. So little slowly we'll start first. Uh, if you go through the syllabus, you can see there the next module, integral calculus. We will be lot of things here. One by one we'll start. So first of all, the basic thing, that is the fundamental theorem of integral calculus. The fundamental theorem of integral calculus. So what was that? Whatever you have studied till now in definite integral, that is actually based on the fundamental theorem. So uh, if we consider a definite integral like this, integration a to b f of x dx, where we have not crossed out anything, where we have some infinity cases there. So all a b are finite and f of x is also having finite value in the interval a and b. That was our assumption, whatever you have done still. So the fundamental theorem is that if f of x is a continuous function over the interval ab, if f of x is a continuous function over the interval ab, and f of x, capital F of x, is an antiderivative of f of x, that means what? We can say that f dash x is equal to f of x. So if there is a function capital F of x which is the such that f dash x is equal to small f of x, then we can write integration a to b f of x dx is equal to fb minus fa. That you know. So what is the, if you write here a to b, this is f dash x, capital F dash x dx, then you know this integration will be f of x from a to b, that is fb minus fa, that you know. Now we just study in the name of fundamental theorem of integral calculus. So this is
Excuse
known
me,
as,
sir.
bolo, bolo.
Sir, Anmol Sharma cannot join the meeting. He is telling me that please let him to join the meet.
Let him know that there are 3 meetings. One is Tuesday's class, one is Wednesday's class, one is Friday's class. He is clicking on the right link or not.
Okay, sir.
Okay, ask him to join through the Friday's meeting. Someone is joining in others meeting, that's why creating this problem. So please ensure that he is joining in Friday meeting, the link I have given, the link all. Okay, let him know. So this is the fundamental theorem of integral calculus. Now we'll study mean value theorem of integral calculus. Before going to that part, let me know from you, is Firoz sir already talked about the mean value theorem for differential calculus? You have this mean value theorem for differential calculus. Let me know. One or
Yes,
two
sir.
people just respond.
Yes, sir.
Yes, sir.
Okay,
Bannerjee has
okay,
Yes,
already
okay,
sir.
okay. Fine, fine, fine.
Not
Then
for
you,
differential. Yes, sir. Differential.
for differential calculus, that you know.
Yes, sir.
So I will just repeat once again. I will not going to go detail in the differential calculus. We will just, this is the extension of that part. This is nothing but mean value theorem of integral calculus is just an extension of the mean value theorem of differential calculus. So what was there in differential calculus? That uh, we have there, that if capital F of x, if I consider capital F of x is a continuous function, over the interval ab, and f of x is differentiable, f of x is differentiable over the interval ab, that is the open interval ab, then there exists a point c in ab, at least one point c in ab, such that f dash c will be equal to, capital F dash c, so will be capital F dash c, capital F dash c will be equal to fb minus f of a by b minus. That was okay. All of you, please mute your microphone. All of you, please mute your microphone. So this is the mean value theorem for differential calculus that we have studied by Firoz sir already talked about. Now there is an extension. If small f of x, a function, a small f of x function which is continuous over the interval ab, then there exists at least one point c in this ab such that fc will be equal to 1 by b minus a b. Sorry, this will be a to b. There is a mistake. This will be a to b f of x dx. 1 by b minus a to b f of x dx. And this value is known as mean value of this function f of x. This value fc is known as the mean value of f of x in the interval ab. This is the mean value of the function f of x in the interval ab. Please, all of you, mute your microphone. Someone is unmute. Please ensure that your microphone is muted. So this is the mean value of the function f of x in the interval ab. So now, so what actually we will do? You see, this is our mean value theorem for the function. Now, if f of x is a continuous function over the interval ab, and if f of x is integrable, then we can say there exists a function capital F of x. There exists a function capital F of x such that small f of x is equal to capital F dash x, simply. So you can say, if you apply the mean value theorem for differential calculus on this capital F of x function, you will get f dash c is equal to fb minus f of a by b minus c. And what will be your f dash c? F dash c will be small f of c, that will be equal to 1 by b minus a into fb minus fa. By using the fundamental theorem of integral calculus, fb minus f of a will be what? Integration a to b f of x dx. Simply this is an extension, or in other word you can write like this: integration a to b, here also integration a to b f of x dx is equal to b minus a into fc. This is called the mean value theorem for integral calculus. What actually geometrically representing by this mean value? Suppose we have a function small f of x, here this small f of x like this, and we have also, this is your f of, this is your a, and suppose this is your b, and this is your f of a, this is your f of b. By means of this existence of this mean value means there will be a point somewhere in between a and b, suppose somewhere at c, such that this fc will be like this here. Then what actually saying, if you draw this rectangle, now see, this area will be what? This area value will be, this area will be f of c into b minus a. This is the area, this area. If I write this name as a, b, c, d, then this is actually the area of this rectangle a, b, c, d, by means of this. And also by means of this integration, what actually we mean? We mean that area under the curve f of x, area under the curve f of x, that means area under this curve f of x means this red line area, this area is. So actually we are saying that this area will be equal to the area of this rectangle. That means this portion of area is equal to this portion of area, this area. This is actually saying by this mean value theorem. Okay, so problems here will be like this. Problems from here will be like this. Suppose if I ask you that find the average value of the function, f of x is equal to 8 minus 2x over the interval 0 to 4, and find some c such that this fc is the average value. Simply if I ask you this problem, what do you actually want to do? We want to get the mean value of this function. So mean value will be given by the mean value theorem, that fc is equal to 1 by b minus a integration a to b f of x dx. Here this f of x is equal to 8 minus 2x. Just simply put it. So this will be 1 by 4 minus 0, 0 to 4, 8 minus 2x dx. Integrate this. So you will be having 1 by 4 and this will be 8x minus x square 0 to 4, that is 1 by 4 32 minus 16, that is equal to 4. The value will be 4. So the average value of this function in this interval will be 4. Now what is next? That find the point C such that FC will be equal to the average value. That means what we actually have? FC you need to find 4. For what value of C we will be having FC is equal to 4. That means 8 minus 2 into C, this equal to 4. That is implies what? C is equal to 2. So at C is equal to 2, we will be having the mean value and the mean value will be 4. At the point C is equal to 2, which will be belong to this interval, which must belongs to this interval, and at this point, what is the functional value? That is the mean value is 4. In this way, the problems will be given. Someone is unmuted. Please mute your microphone.
Sir, can you explain the graph once again?
Which one?
Yes, sir. The geometrical interpretation, sir. Can you please explain it again?
Okay.
So the graph,
This graph. No.
yes, yes.
Okay, let me explain again. Here, I'm not going to prove it. I'm just explaining that what is happening by this integration a to b f of x dx. Mean value theorem says this value will be equal to what? B minus a into fc, or there exists at least one point c such that b minus a into fc. Okay, one point c. This c belongs to belongs to anyone at in this interval a to b. So what this graph represent, this integration represents, that area under this curve is unknown. Area under this curve. So
Yes,
suppose the function f of x is like this. Suppose and this is suppose this point is your f of b, and this is b. This is somewhere at b, and this is somewhere at a. So this value is f of a. This value is f of b. So by this integration, we are meaning the area under this curve, means this area. This area we actually representing. And by mean value theorem, it is saying that area will be b minus a into fc. So there exists a point. There must have one point in between AB, somewhere at here, this C, where this fc, this is your fc. And if we draw a rectangle passing through this point C, passing through this point C. Okay, so you see this rectangular value, let me take one color. This rectangular value, this area will be what? This area will be what? This is a rectangle. FC will be what? This is one is FC. So this one will be your FC. This part, this portion will be your FC. Also, this portion will FC will this one. So this area, total area will be what? B minus A into FC. B minus A into F of C. So this area actually equal to this integration area. Understand? This is mean by mean value theorem.
Okay, sir.
Okay. And in I think you know the geometry about the differential mean value theorem for differential calculus. No, I think.
Yes, yes, sir.
Okay.
That we did this class.
Okay. So now,
हेलो
हाँ बोलो.
सर, जो आप लिखे हैं एफ डैश सी इक्वल टू एफ बी माइनस एफ ए अपॉन बी माइनस ए लिखे हैं,
हाँ,
तो सर वो तो कार्ड का स्लोप हो गया ना, तो आप टेंजेंट का स्लोप उसके इक्वल क्यों कर दे रहे हैं?
टेंजेंट कहाँ गया?
मेरा मतलब सर वो कहना है जैसे कि आप एफ बी माइनस एफ ए अपॉन बी माइनस ए कर रहे हैं,
हाँ,
तो ए पॉइंट और बी पॉइंट का एक कार्ड का स्लोप वो होगा, तो सर उसके इक्वल टू आप एफ डैश एक्स कैसे कह सकते हैं?
मुझे समझ में नहीं आया क्या बोला तुमने. बताओ एक बार फिर
सर
से बताओ.
मैं ये
प्रॉब्लम
कह रहा
बताओ.
हूँ जैसे सर मैं ये कह रहा हूँ जैसे कि एफ डैश सी जो आप लिखे हैं इक्वल टू एफ बी माइनस एफ ए अपॉन बी माइनस ए,
हाँ,
तो सर अगर हम एक पॉइंट ए ले रहे हैं, एक पॉइंट बी ले रहे हैं,
हाँ,
तो उसके बीच का कार्ड का ये स्लोप होगा ना, तो सर आप उसके इन जनरल एफ डैश सी क्यों लिख दे रहे हैं?
हाँ, कॉर्ड का स्लोप होगा ना. ये पार्ट
तो
बोल
सर
ये पार्ट बोल रहा हो ना तुम. इस
जी
पार्ट
जी
में
जी
बोल रहा
सर,
हो.
जी जी
एफ
जी
बी माइनस एफ ए बाई बी माइनस ए, दिस इज व्हाट?
जी सर, ये तो कार्ड का स्लोप होगा
कॉर्ड का स्लोप होगा. और ये क्या है?
जी,
इसीलिए मैं
लेकिन सर
पूछा
आप
ना.
Lagrange
एफ
mean
डैश
value theorem.
सर
इसीलिए मैंने
सर
पूछा कि तुम
सी
डिफरेंस. लिसन टू मी. इसलिए मैं पूछा कि मीन वैल्यू थ्योरम डिफरेंशियल कैलकुलस में हुआ है कि नहीं. क्या था वहां पे?
वहाँ पे
एक
सर ये तभी वैसा था जब उसके नेबरहुड में होता था, लेकिन सर इसके नेबरहुड में है ही नहीं।
नेबरहुड में
मतलब सर उसके जस्ट अप, मतलब कि एक पॉइंट के आसपास वाला पॉइंट होता है तब ये स्लोप वैलिड
आसपास
होता
वाला
है सर।
नहीं है. आसपास वाला नहीं. ए बी में एक ए बी के अंदर एनी वैल्यू सी, दिस सी एक्चुअली ए लेस देन सी लेस देन बी, नथिंग एल्स. कहीं
जी
नेबर
जी
पे
जी
नहीं है. तो ठीक है, ये सपोज कैपिटल एफ ऑफ एक्स. यहाँ पे सपोज दिस
जी
इज
जी
वन इज योर कैपिटल एफ ऑफ एक्स. ठीक है.
जी
तो यहाँ पे
जी
दिस इज योर एफ बी, दिस इज योर एफ ए, कैपिटल एफ ऑफ ए. दिस इज योर कैपिटल एफ ऑफ ए. तो देयर एग्जिस्ट ए पॉइंट, मतलब क्या, यहाँ पे देखो ये सी पॉइंट में मान लिया, तो ये कॉर्ड ये है, ये स्लोप, इस कॉर्ड का स्लोप क्या है? दिस वन इज योर ए बी माइनस एफ ऑफ ए बाई बी माइनस ए, ये सनो इस कॉर्ड का स्लोप. और यहाँ पे अगर मैं टेंजेंट ड्रॉ करता हूँ सी पॉइंट में, यहाँ पे मैं अगर टेंजेंट ड्रॉ करता हूँ, तो इसका स्लोप और इसका स्लोप सेम होगा ना. यहाँ पे देखो, यहाँ पे मैं ड्रॉ नहीं कर पाया, ये स्लोप सेम होगा.
सर वो
सो
सर वो
पैरेलल हो रहा
सर
है
वो
इसलिए.
थ्योरेटिव से ये कर रहा है, माने रिलेट कर रहा है थ्योरम. जो ये तो एक थ्योरम है ना, इसमें तो हम लोग मतलब एक कंक्लूजन लास्ट में निकाल रहे हैं थ्योरम की तरह. वो डेरिवेटिव का जो डेफिनेशन होता है ना टेंजेंट का, उसको यहाँ से कंपेयर कर रहा है, इसीलिए उसको वो समझ में नहीं आ रहा.
हाँ, तो कंपेयर करो ना, टेंजेंट के साथ ही कंपेयर करो. एफ
लेकिन ये तो
एफ
एक थ्योरम है.
थ्योरम है, पर कंपेयर करो. एफ डैश सी क्या है? एफ डैश सी
कंपेयर
तुम्हारा
कर
क्या है? एफ डैश सी क्या है? एफ डैश सी
एफडेसी
डी डी एक्स ऑफ
माइनस एफ.
एफ ऑफ
सर
एफ ऑफ
एफ
एक्स.
डैश सी तो सी पे टेंजेंट है ना।
हाँ, डी डी एक्स ऑफ एफ ऑफ एक्स एट सी. सुनो, डी डी एक्स ऑफ एफ ऑफ एक्स
Yes,
एट
sir.
सी, दैट मीन्स व्हाट? tan
Yes,
theta,
sir.
tan theta at the point C.
यस सर.
ठीक है ना. तो यही तो स्लोप है, तो ही तो बता रहा है ये
Yes,
थ्योरम
sir.
कि ये स्लोप यहाँ पे इक्वल टू है. ठीक है ना. So that was for differential equation, sorry, ordinary differential calculus. Okay, now come back to my portion. So in this way you have to solve. I am giving two problem here, so you can easily solve. I think these two problem you can do easily. Same problem, that find C f of C, same problem, so you can do. So I will send you this copy so you can do it. Okay. So this now we will be having this. This is the main part, that is the improper integral. Whatever the integrals, definite integrals you have done in your HS, up to that, that was only based on the proper integration. What do you mean by proper integration? If I write integration, a to b f of x dx, this is a definite integral. and this will be proper. This will be proper. What are the criteria for the proper integral? That means it should not have be any infinity case. That means what? Its lower limit, upper limit, both are finite. We have crossed out the problems where a and b both are finite, and also f of x will have finite value, finite real values in the interval ab. Then we say this is a proper integral. If does not happen, that means if either a or b, if either a or b tends to minus infinity or plus infinity, or the function f of x has a finite number of infinite discontinuity. So what are the thing? A or b is plus minus infinity. Either a or b is plus minus infinity, or f of x has fine have finite number of infinite discontinuity. Finite number of infinite discontinuity means at some point in this interval we will be having f of x infinite value. Then we say that integrals are improper integrals. Like suppose if I write one example, like suppose uh, 1 to infinity 1 by x dx. This integral is improper. Why improper? Because we have the upper limit is in, maybe sometimes lower limit infinity. Then suppose these two are finite. This limit range is finite, 0 to 1. But suppose I am writing like this: f of x is equal to 0 to 1, 1 by x dx. Is it improper integral or proper integral? You see, at this x is equal to 0,
Improper.
uh, at this x equal yes, at this x equal to 0, we have the functional value is infinity going to infinity. So there is this one point where we have the function f of x tends to plus or minus infinity. So this is an improper integral. So understand the difference between proper and improper integral. That improper integral will have either the lower limit a or the upper limit b, or there exists some point in between a and b where we have infinite discontinuity. Then we say this is an improper integration. Now you tell me minus 1 to 1, 1 by x dx, is it an improper integral or not? Minus 1 to 1,
Yes, sir. Yes, sir.
improper,
Improper.
because 0 is a
Sir,
point,
not
Improper.
improper.
Yes, improper.
because 0 is a point. Now suppose if I
Yes, sir.
write integration 1 to 4, 1 by x dx. Now it is not improper. This is a proper integration.
No,
Not.
Okay. So
Sir, I have a doubt.
bolo.
Sir, yes, sir, suppose there is an integration of 1 by 1 plus x square from minus infinity to plus infinity. Then is it improper?
Now you say, you tell
1
me.
by x square.
You tell me.
I think, sir, it is not improper because after integration we get a finite value.
After integration, I am
But
not
still
saying about, I have not talked about anything after integration. I have talked only that whether it is improper or proper, it will be having some value or not, that is different thing. I am saying just whether it is an improper integration or proper integration. It is improper integration. Why? Because we have infinity case. Now the value may have. I am not saying that the integration is, if there is some infinity case is there, then always it will be an infinite value. You may have the integration value is finite. You may have integration value is finite. That is different thing. But that is an improper integration. Okay. If you see,
okay,
we will
sir,
have
understood.
finite value. Otherwise, what is the requisition for starting this improper integration? If we know that all the time improper integration will have infinite value, then no need to study that. So now we classify. To understand up to this, that this is an improper integration.
Yes, sir.
Can you please explain the last one once again?
That improper
How this
integration
function is improper?
improper because you just check whether the two limit, you check whether this two limit are infinity. Is there any infinity or not? Okay, first thing. Second thing you need to check whether in between this, if these two are not infinity, but at some point we have some infinite discontinuity, then we say there is an improper integration. Simply, I will not going to study the value.
Okay.
Now I will comment on the value that improper integration may have finite value, may not have finite. If it has some finite value, then it is convergent. If it has not a infinite value, then it is divergent. So improper integration not always convergent. Sometimes it may converge, sometimes it may diverge. You see, for proper integration, you will always have some finite value. For proper integration, you will always have some finite value. But for improper integration, it may have finite value, may not have finite value. So we will study that values or convergences later. First, we classify the improper integration. We will having some classification. Please mute your microphone. One is unmute. Please check once again. Please mute your microphone. Please. किसी एक का चालू है ठीक है someone is typing please stop someone is typing I have to unmute in that mute
Sir,
all the
someone named Deepak is making noise.
Deepak.
Yes, sir. It is
Deepak.
Sir, can you do mute all?
Sir, you mute yourself.
Now I think he has muted.
Okay.
एक्चुअली क्या होता है कोई कोई अटेंडेंस देने के लिए कान खोल के बैठ जाते हैं बस उसके बाद चलो चालू है मेरा अटेंडेंस चल रहा है ऐसा मत करो यार अगर दुकान खुले हो तो कस्टमर को अटेंड करो थोड़ा ठीक है improper integration we classify it first so classifications are improper integration are first classified in two parts one is first kind and second kind improper integration first kind improper integrals second kind in first kind we have also three type of classification type 1 type 2 type 3 and in second kind we have four classification type 1 type 2 type 3 type 4 so these are the classification that is first kind first type first kind second type first kind third type second kind first type second kind second type second kind third type second kind fourth type we will study one by one first kind means if the limiting value are infinity if the limiting value integration a to b f of x dx where we have either a is infinity or b is infinity or both are infinity then that are classified as first kind and second kind if there is if f of x has a if the limits are finite n b are finite but f of x has a finite number of discontinuity in the interval finite number of discontinuity in the interval a to b then any value one or two or more value we have but finite number of values 1 2 3 finite values where f of x will be having infinite discontinuity okay then we classify that are the second kind and type 1 type 2 type 3 if a is minus infinity the lower limit is minus infinity then that is classified as second kind second type we will classify one by one just briefly I am saying here if b is plus infinity then it is type 1 if both are minus infinity and plus infinity then it is type 3 so first we define first kind type 1 we define first kind type 1. First kind means either of the two limits we have infinity, and if the upper limit is infinity, a to infinity, the form is the general form for first kind first type is a to infinity f of x dx. If we have a to infinity f of x dx, then this improper integration is known as first kind first type. And what is the condition for convergence of this integration? That if f of x is bounded and integrable over the closed interval a less than equal to x less than equal to capital B, for all capital B greater equal to a. That means in place of infinity, this infinity first we replace by a finite value b. The thing is like going like this. We will not going to integrate this one. We first replace this infinity as a finite value b, and then we take the limit capital B tends to infinity. Then if this limit, so we'll write a to infinity f of x dx, a to infinity f of x dx is equal to limit b to b tends to capital infinity a to b f of x dx, and we check whether this limit exists or not. If this limit exists, then we say this improper integration convergent, and the limiting value of this will be the value of this integration. Understand? So first, what you need to do, we replace this infinity by a finite value b. Then we find the limit. Now we don't have any problem to find this limit. If you if you're able to integrate this, you can write down the integration value a to b capital B f of
Sir,
x. Bolo.
sir,
Bolo.
sir, what we have to take B means what value we can take B by
Capital
our
B,
own.
capital B, any just variable capital B,
Okay, sir.
capital B, always capital B. Okay. B.
Can you explain the convergency point?
We will take any value capital B, any value capital B. I'm not saying the particular value. You take as B, but B must be greater than A, strictly greater than A. Then we take the limit B tends to infinity over this integration value. Then we get the if this limit is convergent, that means if you limit, you are getting some unique finite value. Then we say the value, this value will be equal to this integration value, and it is convergent. You just take this example. You see, these two are the example of first kind first type. Always we have upper limit is infinity. So from this one first, what we will do, we just replace this infinity by lower limit will be same 0, infinity by capital B, then 1 by 1 plus x squared dx. Now integrate this. Integration will be what?
Tan inverse
Tan
x.
inverse x. So tan
Tan
inverse
inverse.
x, tan inverse x 0 to b. That means tan inverse b minus 0. Yes, that tan inverse 0 is what?
0.
0.
0.
So I am getting the limiting the value is tan inverse b. Now what you need to check, whether taking b tends to infinity, this value is tending to some finite value or not. You see, if you now take limit b tends to infinity over here, so what will happen? Limit b tends to infinity.
Pi by 2.
As b tends to
1.
infinity, tan inverse b tending to what?
The pi by
Pi
2.
by
Pi
2.
by 2.
Pi
Pi
by
by
2.
So
2.
as it is tending to pi by 2, pi by 2 is a finite
Yes, sir.
value.
Pi by 2.
Finite value. Pi by
Sir.
2 is a finite value. So I can say the
Convergence.
integration is convergent,
Convergence.
and the value will be equal to 0 to infinity 1 by 1 plus x square dx is equal to pi by 2. The value will be this. Similarly, this one, what you need to do, same thing. For this, we first find, replace infinity by b, so 0 to b 1 by x cube dx. Then integrate this one, 1 by x cube dx, you integrate and then put the value. You integrate this and then put the value. If you getting not being here, if you getting some finite value, then it is convergent. Zero. No, it not be zero.
Yes, sir, it will be zero.
Divergent.
So it is divergent.
It is divergent.
Yes, sir, it is zero.
Okay, actually,
Yeah.
I should not take
The
this.
lowest it is zero.
Okay, sorry. You see, I should not take this infinity now zero. You take some finite value. Suppose some other value. Suppose one. I should not take zero because that will be some mixed type of integration. So you should not take here
It may
zero.
be undefined.
Now 1 to infinity, it will be okay, I think. For 1 to infinity, suppose this is 1 to infinity, then 1 to b. Now you can integrate easily. I think the value will be coming. This will be minus 1 by 2 x square.
1 by 2.
1 by 2.
1 by 2.
1 by 2. So it is finite value. So it is in convergent. Understand? So in this way, you need to do. Suppose if I take 1 to infinity.
Sir, I am not. Sir, on which basis we divide first kind and second kind, and I couldn't get those points due to my network connection.
First kind and second kind I have defined as that first kind will be a to b, either of a and b, the limit either of a and b are infinity. Either a is minus infinity or b is plus infinity, or both are a is minus infinity and b is plus infinity. If the limits are infinity, then this is first kind. Otherwise, if f of x has a finite number of discontinuity, infinite discontinuity, then it is second kind. Okay, now again again suppose if I ask you whether this integration 1 to infinity 1 by x dx, whether it is first kind first type or not. First check first kind first type or not. Yes, there is no point of discontinuity, only at infinity we have. So it is first kind first type. Now tell me whether this is convergent or not. You see, you will get divergent because you will get log b, and log b, you know, as b tends to infinity, log b will be tending to infinity, so it is divergent. So the improper integration is divergent. Okay, now first kind, second type. First kind, type 2. First kind type 2 is what? B will be finite. F of x, this will also have some finite value for finite value of x, and only we have at this point.
सर
बोलो
सर डाइवर्जेंट वाले केस नहीं आएंगे क्या टाइप 1 और टाइप 2 और टाइप 3 में, कि सिर्फ कन्वर्जिंग वाले केस आएंगे?
अभी तो लास्ट वन क्या एग्जांपल लिया, डाइवर्जेंट वाला केस ही लिया ना,
दोनों आएंगे ना?
कहाँ पे बोलो फिर से।
अरे वो कन्वर्जेंट नहीं है तो डाइवर्जेंट होगा।
यस, एकदम सिंपल पॉइंट है। कोई अगर कन्वर्जेंट नहीं होता है तो वो डाइवर्जेंट होगा।
ठीक है, ओके सर।
पर इनफाइनाइट सीरीज केस में तुम ये बोलो कोई अगर कन्वर्जेंट नहीं है तो वो नॉट कन्वर्जेंट है। मैं इनफाइनाइट केस के लिए, इनफाइनाइट सीरीज के लिए बात कर रहा हूँ। If it is an infinite series, in that case, if something is not convergent, then you simply say this is not convergent. Don't say divergent, because under not convergency we have two things. One is oscillatory, both are same, but you say not convergent. Okay, but here you can say that if it is if something is not convergent, then that will be divergent. Okay, so now first kind, type 2. This is the general format, minus infinity to b f of x dx. Here what will happen, in place of minus infinity we will replace it by capital A. We replace minus infinity by capital A and we do the integration. Then we do the integration. After doing this integration, we take the limit a tends to minus infinity. And if this integration convergent and converts to finite value, then that value will be equal to this improper integration value. So here we have same condition, f of x must be bounded and integrable over the interval a less than equal to x less than equal to b, and a for all a less than b. There we have for all b greater than a, here small for all capital A less than b. Then we define this one where this limit exists. So you see this one is first kind type 2, yes or no? This one is
Sir,
first
the
kind type 2.
limit is, sir,
Bolo.
sir,
Bolo.
the limit is a tending to minus infinity or plus infinity?
Minus
Because
infinity.
in one place.
Minus infinity. Here, okay, sorry. This one is written a tends to infinity.
Yes, sir.
This is
That's
wrong.
why.
This is wrong. This will be a tends to minus infinity. Sorry, this is a printing mistake. Some printing mistake I am typing in that case. Some printing mistake. It is a printing mistake. A tends to minus infinity. What I am written here, that is the correct thing. That I am repeating once again here. Limit a tends to minus infinity integration a to b f of x t. Now it is fine. This limit. So now here also, so we do what? We replace this minus infinity by capital A to 0 e to the power x dx. Now at this point, now you integrate this one, simple integration, we will be having e to the power x a 0, that means 1 minus e to the power a. 1 minus e to the power a. Now check the limit. Limit a tends to minus infinity 1 minus e to the power a. What will be the limit value? 0. 0 or 1.
One, sir.
As a to the minus infinity tends to 0, this will be tending to 0. So that means this will be 1 minus 0, that is 1. 1 minus 0, that is 1. Okay. So the value is, this value will be equal to 1.
Finite, so convergent.
Finite, so convergent, and we'll have this value. So let me stop
And
here.
wherever there will be infinity, we will replace that with some value, like
Yes,
in
yes,
first
yes,
kind
yes.
that will be A, or in second type it will be B.
हाँ, कोई भी तुम ऐसा there is no hard and fast rule दे कि तुम्हें यहाँ पे B लेना चाहिए. You can take capital X. Someone is taking suppose capital X. No problem, no issue. I am writing B for the convenience that it is the limit was small b, so that's why I am replacing this by capital B for remembering. You can take capital X, no problem. Bolo.
Okay, sir.
So the integration is convergent, na, but the series is not convergent, na?
सीरीज एखाने यहाँ पे सीरीज कहाँ पे आया? यहाँ पे तो सीरीज नहीं है. यहाँ पे सीरीज कहाँ है? सीरीज का पार्ट खत्म हो गया है. Series different chapter that we have completed. We have started today the improper integration. यहाँ पे सीरीज नहीं है. ठीक है? Okay. So let me stop here. Before going to that, tell me if any queries, raise your point. Otherwise, I will stop.
So for first kind type 1, one of the limits should be infinity, and for type 2, one of the limits should be minus infinity, right, sir?
Yes.
Okay, sir.
Sir, can you explain the example of that mean value theorem, that average value?
Which one? The example. This one.
Sir,
Yes,
please,
sir.
sir,
Yes,
sir,
sir.
sir,
Average
please
value
explain the
that.
example 1 by x cube.
Huh?
Please explain the example 1 by x cube, sir.
1 by x cube. Which one? Okay, I'm coming back. Before
Previous.
going to that, यहाँ पे क्या है? Find the average value of the function. This average value means this. You can take this is the formula for average value. You can consider this is the formula of average value. Mean value theorem is nothing but telling about the formula about the average value of this function. You see, if I tell you that what is the average value what will be the average value of if something is anything any value taking from 0 to 4 any value, suppose 1 2 3 4, what is the mean value of this? What is the mean value
2,
of this? 1 plus
2,
2
sir,
plus
2
3 plus 4 by
plus
4, like
4.
this we do. For the finite case we will use plus sign, that you know, but 0 to 4 we will be having infinite number of values, yes or no? Infinite number of values. In that case, what we do? We integrate summation. Summation is nothing by replaced by integration. In the, you know it, I think summation always replaced by integration in the case of continuity. So for 0 to 4 we will integrate this, and you need to find the mean value of f of x. If f of x is simply 1, in that case 1 by b minus a is the 0 to 4, 4 minus 0 by 1 by 4 minus 0 is the average value. Similarly, if for a function, if we are asked to find the average value, that value will be 1 by b minus a to b f of x dx. This is given by mean value theorem. This is the formula. So first we find this mean value. So now this mean value, at which point this mean value occurs, that is C. At which point in this interval this mean value occurs, that is C. So first we find the fc value, that is 4. So if you have fc is equal to 4, you know fc, putting over here 8 minus 2c is equal to 4, you will be having c is equal to 2. So you can find this point. So at this point the average value exists, and average value is 4.
Yes,
Okay.
sir.
And
Thank
what
you,
is
sir.
one of you are saying about the which integration, 1 by x cube or something, what you are telling?
So 1 by x cube 1, he was asking.
Yes, sir. 1 by x
1
cube
by
example.
x cube. This example. First
Yes,
of all, I have wrongly taken the first example, that 0 to infinity. Don't take it 0 to infinity. First you take from 0 to 1 to infinity. 1 by x cube dx. This series is convergent or not? This sorry, not series. This improper integration is convergent or not? This improper integration of type first type. For that, what you will do? You replace this not equal to. You replace first this infinity by b, and this is 1, and find out this limit. Find out this integration, 1 by x cube dx. So what will be the integration? 1 by x cube minus 1 by 2x square, minus 1 by 2x square.
Yes, sir. Yes, sir.
1 to b, that is minus 1 by 2 1 by b square minus, we put 1, this will be 1 by 2. Now we take b tends to infinity. If b tends to infinity, this will be what? 1 by 2. Is it correct?
One होगा sir, two नहीं.
Only one.
One, sir.
1 by
One.
1 b square minus 1 by
1
1.
by b square minus
We
1
have
by b
taken
square.
common.
Have I made any mistake?
So 1 by
Yes,
1
sir.
by
We
1,
have
sir.
1 by b square minus
1
1.
by b
Okay,
square
okay.
minus
Sir, 1
So
by 1.
only 1.
Sir, we have taken two common.
The minus 1 by 2 you have
outside,
written,
na?
no, sir.
There.
So you have taken 1 by 2
Sir, here
common. So
1
you
by
don't
b
1
is
by
need to
2
multiply
common.
it again.
Okay,
1 by
sorry,
b
sorry,
square
sorry,
minus
sorry,
1
sorry,
square in the bracket.
1 square.
Now is it correct?
Yes.
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
as b tends to infinity, this value tending to 0. This value is tending to 0. 1 by b square tending to 0. So we'll have sustained only with this minus 1. So minus 1 into minus 1 by 2 is 1 by 2. Is it okay? Fine.
Sir, in your last class, you give some question. Around one question I did not solve, so you can talk about.
First, you discuss with your friends if it's possible to solve by. Okay, which one?
Sir, sine 1.
1 by
Sine
1
1
into
plus
2 into
1.
3 plus 3 by 2 into 3 into 4. that one.
I don't have it now, right now. So the problem was what?
1 by 1 into 2 into
Sign.
3 plus 3 by 2 into 3 into 4 with that one.
Okay, so what is the problem there? We're facing the problem.
With the
At which point? At which point you are
মানে
getting?
এনে আনতে পারছি না, মানে এনের ফর্মে আনতে পারছি না ওটা।
Why? You just do their AP series and GP series format. The nth term you find like this. Suppose something I am saying here. Suppose it is given as 2 by. Suppose it is given as 2 by 3 into 3 by 4 into 4 by 5 into suppose 1 by 2. This is the first term. 1 by 2. This is the first term. Suppose like this if it is first term. So what will be the nth term? Next term is suppose 2 by 3 by 3 by 4, 4 by 5, 5 by 6 into 1 by 3. Like this if it is going. How to find this nth term? 2, 3, 4. Then in first term 2, 3, 4. First term 1 plus 1. So you can write as n plus 1, n plus 2, n plus 3 by
Yes sir.
by this will be what? N plus 2, n plus 3, n plus 4
n plus 2 n plus 3 4.
into 1 by n plus 1. Like this you do.
Okay.
Understand?
Okay.
Sir, one more question I have doubt
Bolo.
in that exercise. Sir, test the convergence of series 1 plus 2 square by 3 square x plus 2 square 4 square by 3 square 5 square x square. How to find the an and how to solve that type of questions in which the each term is itself a
To
series.
write the problem first. I don't have right now actually the problem. Okay, let me find out. This one. Which one? This one.
The first question.
हाँ बोलो यहाँ पे क्या होगा n क्या होगा क्यों ये इसमें n नहीं फाइंड कर रहा है
First question
what will be your n anyone what will be your first term this is 2 square then 2 square into 4 square this is 2 square 4 square 6 so what is changing here 2 4
by 2n plus 1 whole square.
2n square. Each term is in multiplication, so the terms which are getting multiplied are 2n whole square.
So 2 square into
in numerator.
nth term you can write 2 square into 4 square.
So if we ignore the 1, if we look from the second term.
Can I write like this?
Sir, it will be 1 square into 2 square into 4 square into 6
Sir,
square.
and in the denominator, it will be 2n minus 1 whole square. Sir, all the terms in multiplication and the end term will be 2n minus 1 whole square.
No, I'm writing whatever I'm writing. Is it correct or no?
Yes,
Hello,
sir.
sir.
Yes, sir.
But sir, we cannot comply the first term with it.
Okay, I
But
listen.
we
Okay,
got the first term and we write
whatever
the series.
whatever you are talking. Okay, listen to me. Listen to me. Here I have a important thing to discuss. Here, you just listen to me, and that help you a lot. Suppose if I write x y, now tell me anyone that whether it is correct or not. If I write like this.
Yes, sir. From the second term.
From the second it is correct. You are saying that from the second term it is correct.
Yes, sir.
You see, listen to me. If you able to write from the first term, it is okay, no problem. If you unable to write from the first term, you can skip that first term, and you can say that from the next term it is this, because you from an infinite series, if you add some finite number of terms or delete some finite number of terms, that does not hamper the convergence of the series. Understand? make it clear. I am once again repeating. If finite number of term added to some infinite series or subtract from the infinite series, that does not hamper the convergency or divergency of the series. So if you are able to write from the first term, don't bother, you write from the first term and write that, simply write skipping the first term. Skipping the first term, we will be having an is equal to this, no problem, and you just solve it. Okay, is it clear?
Yes, sir.
ठीक है?
Yes,
now
sir.
now you find
Yes, sir.
so what type of test we should use here?
D'Alembert.
D'Alembert decision
D'Alembert,
test.
sir.
D'Alembert decision test. First test, D'Alembert decision test. If you are getting the limiting value is 1, in that case you apply Rabi's test.
Correct.
Okay.
Okay, sir. Thank you, sir.
Okay, fine. So let's stop here today.
Sir,
Have a
one more
nice day.
question, sir.
हाँ बोलो.
Sir, is previous slide में.
हाँ, previous slide किसका previous slide? इसका?
Sir, yes, sir, yes, sir.
Infinite series का previous slide?
Yes, sir, yes.
तो उसके लिए तो मुझे फिर से वहाँ पे जाना पड़ेगा, ऐसा नहीं होगा. इसमें?
No, sir, इससे भी पहले.
कौन सा बोलो, क्या प्रॉब्लम क्या है बोलो.
सर इसमें सर 1/3 + 1/3 + 1/5 ऐसा करके कोई नंबर था. सो उसमें n टर्म नहीं निकल पा रहा था.
इसी में तो 1/3 है, देख पा रहा हूँ मैं. 1/2.
यस सर, वो राब्स टेस्ट वाले में.
यस
रैबिस टेस्ट
वाले. यस सर. या
वो कहाँ होगा, रुको देखता हूँ मैं. रैबिस टेस्ट यहाँ पे होगा. नहीं, इसमें भी तो नहीं होगा. राइट. What is it? This one I think rabbit test. हाँ.
Yes sir, this one.
हाँ. क्या प्रॉब्लम हो रहा है बोलो तुम्हें?
nth सर इसमें nth टर्म नहीं निकल पा रहा.
इसको छोड़ दो, इसको भूल जाओ. ठीक है. उसके बाद यहाँ से सपोज फर्स्ट टर्म, ये फर्स्ट टर्म है तुम्हारा, ये सेकंड टर्म है, ये थर्ड टर्म है. सपोज इसमें निकल पाओगे? 2 3 4 2 3 2 4 2 4 6 7. Okay, you do one thing. I am making one bracket here. Tell me, now able to find or not?
Yes sir.
देखो तो.
Sir,
अब होगा?
2n. Yes sir.
अब होगा, फाइंड कर दो.
Yes sir, yes sir.
ठीक है. ऐसा ब्रैकेट नहीं दिया रहेगा, इसको तुम्हें देख के समझना पड़ेगा. ओके. नाउ मे आई स्टॉप हियर?
Yes sir.